I thought I'd help you guys out and show you maybe a little bit of how to get the derivative of x to the power of a rational number. I think it would help if you saw side by side what we're doing. So let's pretend we have x to the power 2/3, and you didn't know that the power rule worked for rational powers, so we're just thinking, well, I can't take this derivative right as it is, so I'm going to rearrange. So if this was x squared, then I would be able to take the derivative of that. So I'm going to put an exponent of 3 on both sides of my equation. So I have y cubed is equal to x squared. And I can take the derivative of each of those sides using the power rule, and then the left hand side I'll just have to use the chain rule, or if you want to call that the kind of implicit differentiation, it's still the chain rule. So the right hand side is pretty easy. The derivative of x squared with respect to x is 2x. On the left hand side we have some function y. In fact, y is this original function, x to the 2/3 power, and it's being cubed. So the derivative of something cubed is 3 times that something squared. My something is a y, which has a derivative, and we're calling that derivative y prime. So we're just going to rearrange. Y prime, divide both sides by 3y squared, and we get 2. That's not a 2. 2x over 3y squared. Well, that doesn't look right. I started off with x to the 2/3 power. I didn't expect a y in here. So I'll go back to my original, and I'm going to substitute where the y used to be. I'm going to put an x to the 2/3 power. So 2x over 3 times x to the power 2/3 squared. And what do we have there? So I'm going to bring that 2/3 out front, and that's going to be x to the first in the numerator, and in the denominator, let's see, x to the 2/3 squared is x to the power 4/3. Okay? So then the last thing we're going to do, we're going to combine. Let's see, so 2/3, and we have x to the first over x to the 4/3 is going to be x to the negative 1/3. And we like that form. That's sort of what we expect with the power rule. But if you wanted to, you could of course rewrite this as 2/3, and then in the denominator is going to be the cube root of x. Okay? But this is pretty cool because, well, let's go back. At the beginning, we had y equals x to the power 2/3, and if the power rule works, we could get the derivative of x to the power 2/3 by bringing our 2/3 to be the coefficient. And then my new exponent is going to be 2/3 minus 1, which is minus 1/3. Okay. So that's the exact same thing I got. Well, we don't want to have to do this every time, so we'll go back, and I'll try to keep everything side by side for y equals x to the power of any rational exponent. So a has got to be an integer, and b has got to be an integer. That's what a rational number is, a ratio of two integers. So before we take a derivative, we're going to do what we did over here. We're going to raise both sides as powers of b. So that's going to be y to the b is equal to x to the power a over b to the power b is x to the power a. We haven't done a derivative yet. That was just rearranging. So now, like we did over here, we're just going to do the derivative of x to the power a, and since a is an integer, that has a derivative of a, x to the power a minus 1. Y to the power b, we're going to use the power rule, but just like over here with our concrete example, we need to use the chain rule. So the derivative of something to the b power is b times that something to the b minus 1 power. Our something is y, which has a derivative of y prime. So we rearrange, divide both sides by b times y to the power b minus 1, and y prime is a, x to the power a minus 1 over b, y to the power b minus 1. Again, we're trying to show that the power rule works for these rational exponents. So I expected to have an a over b out front, and I do have that a over b out front. but I don't really know what to do with this y. As it turns out, we're just going to resubstitute x equals a over b in place of y. So y prime is, I'm just going to bring this a over b out front. It's kind of what I want. And then I'll have x to the power a minus 1 over, well, I'm going to put something in there, to the power b minus 1. What am I putting in? Well, y is x to the power a over b, which means our derivative y prime is a over b. And let's leave the numerator as it is. X to the power of a over b times b is a. A over b times negative 1 is negative a over b. And we have to do some simplifying here. A over b times x to the power. Well, if you're dividing bases that, or the same base, you're going to subtract exponents. So that's going to be a minus 1 minus a minus a over b. And so my first derivative is going to be a over b, x to the power, well, a minus a is 0. Negative 1, I'll just write minus 1 here. And I have minus a negative a over b, or minus a minus a over b is a over b. So that is how you show that the power rule works for rational exponents. Good luck with your explanation.